Hello everybody. My name is Aleksi Mäkilä from a company called Lidarite. I think the Lidarite is more easier to say in English, but it's Lidarite. We are a Finnish company. And I'm here to talk to you about something about automated data collection meets real-time intelligence. So how we can combine the AI for the drone docking systems. Here's something about me. So I am the Chief of Operating Officer in Lidarite and also the founder of the company. I have 13 years of hands-on experience in industrial maintenance, and I'm self-taught SolidWorks modeler and mechanical designer. I love 3D designing and 3D scanning and point clouds. I think the point clouds are the best thing happened to me in my life. So pretty interested about it. So here we have the automated data collection meets the real-time intelligence, because the DJI Dock 3 enables fully automated remote controlled drone operation, allowing drones to be deployed, flown, charged, and stored without the need for on-site personnel. This hardware platform creates a reliable and scalable foundation for continuous data collection in demanding environments. By integrating the DJI Manifold 3, advanced onboard computing and AI capabilities are brought directly in the drone workflow instead of merely capturing the raw images, videos, or sensor data. The system can analyze the incoming data in real time during the flight. This means that the data is no longer just collected. We can process, interpret it, and filter it instantly. So the drone can make its own decisions about the data and the inspections. So we don't need anymore to collect the data, then transfer it in our laptop, and then start to look it with human eye. So we can make AI to do that job. So critical events, anomalies, or changes are detected without human intervention. Only relevant actionable information is forwarded to operators or backend systems. The result is shift more reactive manual data review to proactive and insight-driven drone operations. And from post-processing to real-time data decision support. Traditionally, drone operation rely heavily on post-flight data analysis. This means that when we are flying the drones and we are collecting the data, we always have to go and search the data or process it ourselves. By combining the DJI Dock 3 autonomous operational capability with Manifold 3 AI-driven onboard analytics, this bottleneck is eliminated. The system is capable of performing real-time object detection, anomaly recognition, and pattern analysis, flagging critical findings immediately during the mission, supporting autonomous responses such as mission rerouting or target data capture. This approach accelerates situational awareness, reduces human workflow and error, improves clarity and confidence in operational decisions. The drone becomes not just a data gathering tool, but an active decision support system. And now we are creating new business models with the Bruvo AI expertise. While the hardware ecosystem for automated drone operation already exists, the next major value leap lies in intelligence, AI-driven decision-making. By integrating Bruvo's skilled and solution-oriented AI software development team into this ecosystem, it becomes possible to design custom AI models tailored to specific industries and use cases, transform raw drone data into business-critical insights, build entirely new operational tools and workflows for automated drone services. Together, DJI Dock3, Manifold 3, and Bruvo's AI expertise enable scalable autonomous drone operations, real-time intelligence without past processing, new service models, efficiency gains, and competitive advantages. This combination lays the foundation for the next generation for automated intelligence drone business. Because now we have the good hardware, we can use the drones automatically or remotely, like DJI Dock or different kind of docks. Now, when we are adding the AI to it, we can get more real-time data faster and reliable without the human eye. Here's my slides, and now I will ask here Mr. Tommi Jalkanen to continue. Give applause.
Okay, good afternoon everyone. My name is Tommi Jalkanen and I'm a co-founder of Bruvo. And I'm actually here to spark some curiosity for operating edge AI on your drones and maybe also reconsidering how you're managing your fleet today at your organizations. So for many years, we've had drones as sort of flying cameras. This is how we've been operating it, and as you can see, it served us pretty well. But there's one fundamental flaw with this approach, and it is that when we collect data and then we get sensory information, telemetry and other raw data, we shuttle it back to the servers or data centers or someone's computer for further analysis. The reality is that the world doesn't stop while we're traveling data. And that's the key issue. So whether you are actually delivering supplies or detecting wildfires from the air or monitoring your industrial pipelines, the decisions that matter the most will not wait for a loop back from the server and coming back. 6 hours later, you might not have a forest. And that's a key issue. And I'm going to explain one way of making your architecture so that you can actually move from the data centers to having the thinking being done on the drones. But first, a little bit about Bruvo. So Bruvo AI is a data and AI consultancy company. And as you all might know, AI has been on the lips of everyone and their dog. And these are quite uncertain times. We don't know where AI is heading. There's multiple different paths that it could take us, and it will have huge causes on how we manage our municipalities or countries and development processes. So our mission is to shape a path to a future worth living. And we do this by exploring new opportunities and crafting long-lasting solutions that actually connect people with the technology. And we're not doing this alone. We're a small company of around 10 people, but we're a part of a bigger family of consultancies, so we can serve different customer needs under the same roof. So whenever we get some problems that we cannot solve by our own, we can lean on the extended family of experts for help. And here are also some of our clients that are relying on our expertise to turn their data needs and hopes and opportunities into measurable business value. Now let's get back to the drone issue. First, before we actually introduce a new way of doing things, we actually have to talk about how AI is being developed today and what are the issues when it comes to drones with these. And I've put them as like 3 core issues that I would like to emphasize. And the first part is the infinite compute assumption. So nowadays, most of the developers, they don't even know how memory works or what hardware they're running on. And that might not be an issue because you can use higher level programming languages and then deploy them. And if you find out that this heavy model that we're actually training, it's not working on the server we're using, you can just push a button, throw some money, and get a bigger machine, and all's good. But that's not the case with drones. When you buy a drone, you get a fixed hardware, and if it doesn't work on the hardware, well, then you can, of course, buy a bigger drone or send it to the server like we talked, but that's not how we want to roll. And another key issue is actually taking the models into use. So we train models, they have a perfect data set, and then when we turn it into real life use, suddenly we notice that all the sensors are not providing reliable data. There's some noise, or the weather conditions are not quite like in the simulation, or other unpredictable events like other drones flying in the same airspace and they might crash. So obviously we have to take these real world events into consideration and not just freeze a model and expect everything to be dandy. And the last part is connectivity reliance. A lot of modern development relies on external parties, network connections, API calls. But if we're flying a drone and suddenly the signal breaks, now we're flying blind, and that's not good if our AI is thinking on the cloud. So what we can gather from this is that drones are not miniature data centers. They have 3 key constraints that I've put here on the triangle, vertices of the triangle. And let's start with the first one, which is payload. We just cannot put more load on the drones and expect to fly. Well, at some point it gets too heavy and it will lose its ability to fly, which is probably one of the most important aspects of the flying drones. I saw some land drones, maybe they are okay, but the flying ones definitely you just can't just add more data or load out to them. And then there's the power issue. We also can't fly tethered all the way to an external battery system. That wouldn't work. We couldn't fly very far. So we need to think about power as a scarce, valuable resource. And finally, the compute. So as I said, we have a fixed hardware and fixed computing capabilities. Sometimes if the chip is not strong enough, then we can simply do some of the calculations, and we'll have to think about novel approaches to fulfill our needs. And you've probably also heard this a lot. Data is the new oil. You can't do anything without prior data. You can't make bricks without clay. But here's the hopeful part for drones. This is not entirely true with drones, and I've not heard much talk about this, so this is why I wanted to highlight this part. So I'm going to show you an architecture model that works even if you don't have any many hours of video like the Finnish border control. You'll be able to get set up and operate with AI. And here it is. So first part, like we heard today earlier, also some people are already calculating their models in a simulated environment. So we can make varied synthetic worlds where we can safely train our drones, and there it's actually okay to crash into the walls, and it might be even an exciting new thing to try if the drone goes faster that way. Or you can set things on fire, and we are not losing valuable resources. And there's also even reinforcement learning and other techniques where you can let the AI do its thing without having any prior knowledge of the real world. Once we've made actually our models that don't fly into the walls unless you want them to fly into the walls. Then we can deploy our models into the production where they are ready to be taken in the missions and trying out in the real world. And the third part is online learning. So now that we actually have our model, and it's not a frozen model, we can tweak our model and add the unpredictable real-world environment data into it. And this way, we are constantly learning new things and adapting our solution. And last, we can filter all the insights we got from the flight, put it into the simulation world again, and our entire fleet will now learn. It's not just that one drone that's adapting in the real world. All the other drones will also adapt from each other's experiences. So now that we have a nice model, why on earth would we build it? So this is why I have this slideshow here. So first of all, we are now using our existing resources. So you've already spent a lot of time, money and time on your drones, and probably they're not using their full capabilities. And as a bonus point, you don't have to go to your financial departments and ask for more money. You can actually use your drones to the max, and you'll not be hit with all the resource constraints that we have with these global crises, or not being able to manufacture enough chips or memory and it being really expensive. So we can a little bit sidestep those issues and reduce our costs and wait time. And the second part is longer missions. A lot of the ready-made solutions are built with highly inefficient languages. They might not even actually work with your drones because sometimes you have to go close to the metal to make your solutions with low-level programming languages. So here, when we have highly optimized edge compute, it actually can lower significantly the power draw, and we can fly for an extended period of time. And the third part is the nicest part. Maybe you can fly completely offline. You don't have to have a Wi-Fi access. If you're flying in a coarse terrain, then you might not even have any connectivity there. So now you can actually do flights that previously you might not have been able to do with AI. And also the fourth part is you can already start making decisions where it matters, like in the field. Like previously, you would have made a flight, gathered some info, went back to your HQ and noticed that, oh no, we need another trip. Now, before leaving, you could actually already start doing the things that you would have wanted on the first go. Well, this also was quite nice, but I'm trying to make you aim a little bit higher. So instead of having automated unmanned operations, which usually mean that you have a remotely connected human operator, think bigger and go with autonomous fleets. So with autonomous fleets, you could this could help with three core issues. One is that you can eliminate the manual control. So you can offload a lot of the flight execution to the AI, and this frees resources for the human operator to think about what are actually the critical goals we want to achieve in this mission. And second part, you could survive difficult flights. So sometimes when you have a human operator somewhere in a long distance away, and you add delays from the link and also from human reactions, well, sometimes this is simply just not fast enough to avoid some of the disasters. So you can get safer missions with near real-time adaptation to difficult events occurring during the flight. And the last part, human needs sleep. If you're flying in a really difficult mission, we no longer need the perfectly rested human operator, nice, pristine weather conditions, or highly trained pilots to be able to do critical missions. And I think it's quite important that we can do the flights every day. without fault. So that's it. If this piqued your interest and you would like to unlock the full potential of your drone operations, then come say hi to our partner Lidarite and us at the showroom. Thank you.